All right, back to our proofs. Back in our notebooks. Page 33, 34, and 35. So this is page 33, 34, and then the next one will be 35. Okay, so this right here is a full-blown geometry proof. This is some work that we did in the first unit, and this is an example proof to give you an idea of what to do with the proofs we're going to be working with on 34 and 35, and also in your, why is this going dead? And also in your, what am I trying to say? In your packet. All right, so we have this picture here, and we are told that angle ABC is 80 degrees. So this whole thing is 80 degrees. And so it wants me to prove that ABD is 27. So back in Unit 1, a problem you saw on your test and problems we worked in class, it would say find the measure of ABD. It would say if ABC is 80, and it gives you this information over here with the two angles here. What you would notice, hopefully, is that those two smaller angles add up to the larger angle. So using angle addition postulate, again, from Unit 1, we know that AB, this should be a D. Let me change these. There's typos here. Measure of ABD plus DBC equals the whole thing. So these two smaller angles, and I'm going to make them red. This angle plus this one right here would add up to the whole thing, okay? So then we would just plug in, or you guys would actually start right here, and you would write the equation. You would take the two smaller angles and add them up and equal 80. You would combine like terms, divide, or actually subtract, divide, okay, and you would get x equals 8 after you did the work, solving for x. And then since it wanted us to find ABD, we would just plug it back in. Let's see, where is it? Right here. ABD is right here. We would just plug it back in 3 times, and we got our x is 8. 3 times 8 plus 3 is 27. So this right here is work that you guys did on problems in Unit 1 and on the Unit 1 test. The only thing we're adding to it is the different reasons. Okay, so angle addition postulate, then we substituted in the expressions for each angle, and then we did our algebra to solve it. So let's take a look at some problems. We're going to use very similar reasons for these. Okay, so on page 34, that'll be 35. On page 34, remember we always start with our proofs. We're going to write the given first. I'm going to abbreviate that. Midpoint of XZ. Have a nice picture there for us. Okay, so if y is the midpoint, then I know that these two segments, XY and YZ, are equal to each other, and that would be because of the definition of midpoint. Okay, definition of midpoint. Now I'm going to take the information from the picture, and I'm going to substitute in for XY. I'm going to put 8m plus 5. For YZ, I'm going to put 6m plus 17. And that's just substitution. Let me correct this up here too. That should be an M. We're solving for M, not X. Okay. Now the rest of the space we're going to fill up with all the steps. Let's solve this algebraically. The next thing I would do would be to subtract 6m from both sides. So subtracting from both sides would be subtraction property. The next step I would do is I would subtract 5 from both sides. So subtract 5 from both sides is subtraction again. So I'm going to just use my ditto marks. Subtraction again. And then lastly, to solve for m, I would divide both sides by 2. And I am done at that point, and I just use the division property to finish that problem. Perfect. All right, second example. Let's see what we have here. Let's start with our given statement. QWX is a right angle. That was given to us. It looks like we're going to be solving for x, so we need to make an equation. The step 2, the reason is definition of right angle, so I'm going to say QWX equals 90 degrees, or the measure of QWX would equal 90 degrees because it's a right angle. And then I actually, for between 2 and 3, I would have added another step for show an angle addition and then substituting. But what they did right here is they used the angle addition postulate and substitution kind of together to say that, to say that this angle 2x, oh no, they haven't done that yet. Never mind. That this angle here, QWT, the one on top, and then the TWX, the one on the bottom, add up to 90. Okay, that would be angle addition postulate to replace the QWX. Then we would substitute. So substitution property, go ahead and write it. You would take the QWT is 2x. I'm going to put 2x in its place, substitution. And the TWX is x plus 6. Substitute that in. And that equals 90. So I plug those in, and that in. The rest is just going to be solving. I need to combine like terms for my 2x and my x. So that reason would be combine like terms. Then I would subtract 6 from both sides. Subtract from both sides, the subtraction property. And then lastly, divide both sides by 3. You get 28, which check is what we wanted, so that's division property. Very good. Okay, let's look at page 35. So we know we're going to start. AB equals 50. That's given. Now I'm going to show, since we don't have a lot of information here, I'm going to show what number 2 left out. I would say for my second step, where it says segment addition postulate, I would say that AC plus CB equals AB. I would do that. And then by substitution, I would say that AC plus CB equals 50 by substitution. All right, then I would substitute again, and I would plug these in. So for AC, I would say 2x minus 2. For CB, I would say 4 times x plus 1, and I know that all that will add up to 50. I'm going to need to, I see those parentheses, so I'm going to need to distribute first. And then combine like terms. Kind of jumping around here a little bit. Distributive. Okay, I did that. Combine like terms, I'm going to do 2x plus 4x is 6x, and negative 2 plus 4 is 2. So combining like terms, I get my equation down to that. Then I'm going to subtract 2 from both sides. Subtract from both sides, subtraction property. And then lastly, I'm going to divide both sides by 6. So x equals 8, that's where I'm going to stop. It doesn't want me to plug anything back in, so I'm going to stop. That was division property. Okay, and then lastly, problem 4. I'm told that PF is an angle bisector of angle EPG. That's given. And so what does that mean? The definition of angle bisector, it means that EPG is cut in half. And so angle EPF equals angle FPG. And so then if I substitute the algebraic expressions in, I'm going to have 4x plus 2 equals 6x minus 10. And then you can just keep going with the algebra to solve. I'm not sure how many steps I used here. I think the class, we may have done this in class, I think most people decided to subtract the 4x first. And so that would give you that. So subtraction property. Okay, and then add 10 to both sides. Add 10, so it'd be addition. And then divide by 2. Division. But that is not exactly what I wanted, and it needs to be exact. I want x equals 6, so I'm going to have to flip it back around and use symmetric property. I will say that if you took a different turn on this, and if right here, let's see, where to be? Yeah, right here, instead of subtracting 4x from both sides, if I had subtracted 6x from both sides, oops, it's running off the page, equals negative 10. Okay, if I had done that, then I would have gotten my answer one step sooner. Let's see, then if you subtract 2 from both sides and then divide by negative 2 is 6, I would have been done here and I would not have had to use the symmetric property. So when you're like free solving and doing your own thing, your steps, you can have different steps or in different orders because you may not do what I do or whatever. So, all right, and that's it. Algebra in with geometry.